At a local grocery store, avocados are sold for $5 per bag and mangoes $12.50 per box. A bag consists of 6 avocados and a box contains 15 mangoes. Only a whole number of bags and a whole number of boxes can be purchased. On Friday, a chef purchased 12 bags of avocados and some boxes of mangoes. If the total cost is $135, how many boxes of mangoes were purchased? So our formula will be 12 bags times $5 each, right? And then we don't know the number of boxes, so we'll just use X. And we know the price is $12.50. And then that is $135. So that's your equation. And when you solve that, you will get X equal to 6. So 6 is the number of boxes of mangoes that he bought. On Saturdays only, there is a 10% discount on the price of a bag of avocados and a 20% discount on the price of a box of mangoes. What is the total cost for 8 bags of avocados and 4 boxes of mangoes? So we've got a little bit of a discount. So we've got 8, but instead of 5, we're going to multiply by 0.9 to accommodate for that 10% discount. And then for the, the boxes? Yeah, boxes of mangoes, that's 4. And then there's a 20% discount. So the 12.5 price, we're going to multiply by 0.8 to accommodate for that 20% discount. And when you crunch out these numbers, you get 76. On Monday, the chef needed 100 avocados and 70 mangoes. The chef purchased just enough bags and boxes. Determine how much the price was. All right. So we want 100, right? So each what is it, bag, I think? Each bag contains 6. So that's 16.66. But there has to be a whole number, so we've got to buy at least 17 of those guys. 17 bags. And similarly for the mangoes, he needs 70, but each box contains 15. So that's 4.6 approximately. But we have to have a whole number, so we've got to buy at least 5 of those. So we've got to buy 17 bags of mangoes, so that's $5 each. $5 per bag, I should say. And 5 boxes, and each box is $12.50 for the mangoes. And this is $147.50. So that's pretty much how that goes. And then finally, on Tuesday, the chef made special tarts that each required 1 avocado and 2 mangoes. If the chef spent exactly $75 on avocados and mangoes, determine the greatest number of tarts that she could have made. Okay, so let's see here, $5 plus times the number of bags of avocados, and then $12.50 times the number of boxes of mangoes. So I'll represent them by A and M, and that's going to be 75. So this is the equation, because they're telling you it's exactly 75. So I think we're going to have to make a table here and sort of experiment. So I'll put the number of bags, avocado bags, number of avocados, number of boxes of mangoes, number of mangoes, and then the number of tarts. Working, of course, with that equation. Okay, so let's just start. We've got to have some tarts, right? So that means we've got to have at least some mangoes. Let's just start with 1 here. And if that's 1, and you plug this into the equation, this becomes 17.5. Okay, but that doesn't work because we have to have whole numbers, and that's not a whole number. Okay, so let's do 2. That gives me 10 if I plug it into this equation. Number of avocados will therefore be 30 because each bag contains 6. And number of mangoes will be 30 because each box contains 15. So there's 2 boxes. And the number of tarts is going to be 15 because for every 2 mangoes, we got to use 1 tart. So we're only going to be able to make 15 tarts. Okay, let's keep going here. I'm going to skip 3 because if I put 3 for M, I won't get a whole number here. So let's do 4. 4 will give me 5 for A, and that means this is 30 and this is 60. And therefore, the number of tarts will be 30. And then if I go up to 6, this will be 0, and then therefore that's going to be 0 also. So it looks to me like the greatest number of tarts is going to be 30, and that happens when those numbers are plugged into that equation. The parabola with equation y is equal to x squared over 4 has a vertex at the origin and y-axis as its axis of symmetry. For any point PQ on the parabola, we can form a parabolic rectangle. The rectangle will have one vertex PQ and second vertex on the parabola, and the two other vertices on the x-axis. Parabolic rectangle with area 4 is shown. Parabolic rectangle with one vertex 6, 9. What are the coordinates of the other three vertices? All right, so let's just make a little diagram. So this is my parabola, or parabolic vertex, or what is it called? Parabolic rectangle. All right, great. So they're saying that one vertex is 6, 9. So that's 6, 9. Okay, so that means that this must be 6, 0, since it's on the x-axis. Let me just double think about, yeah, 6, 0, because the y-coordinate is 0. Okay, so then on this side, this is obviously minus 6, 0. And this is obviously minus 6, 9. And I believe those are the vertices. Part B. The area of the parabolic rectangle with one vertex is minus 3, 0. Okay, so same sort of story. Let's do this. So again, we're going to have some rectangle. One is minus 3, 0. So I believe that's going to be this one right here. This is minus 3, 0. So that means this would be 3, 0. And then, to get these points, I've got to use this formula here. So the formula is y is equal to x squared over 4. So to get that point, I'm going to sub in, obviously, 3 for x. So that's going to be 9 over 4? Yeah, 9 over 4. Okay, so that means that point is 9 over 4. Or sorry, 3 9 over 4, because the x is 3, and then 9 over 4 is the y-coordinate. And then this, of course, this point here would be minus 3 and 9 over 4. Okay, so then the area from here to here is 6, and then from here to here is 9 over 4. So that looks to me like 54 over 4, which is 27 over 2. Which is 13.5 if you want to write it in decimal format. All right, moving right along. C, determine the areas of the two parabola rectangles that have side length 36. Okay, so 2 this time. So let's draw a little diagram. And side length 36. So the first scenario is if this side is 36, this side right there. So that would mean that, well, whatever this is 0, this is something 0, and this point would be something and 36, right? Because the height is 36, and this point, of course, would be something and 36 also. Yeah, I think. Okay, now I got to figure out the x-coordinates, so I've got to use that formula, y is equal to x squared over 4. And then y is 36, and this is x squared over 4, so that's what, 144 is x squared, so x is 12. Okay, so put 12 in there, and so on. Hold on, let me see. That's minus 12, actually. Let's make sure I do this properly. Minus 12 and minus 12. Okay, so the area, therefore, it's 36. That's this side. And then this side, be careful, it's not 12. It's 12 and 12, so it's 24. So 36 times 24, which is 864. Okay, so that takes care of the first guy. And then we have another one, because there's 2. So let's do this again. And by now, I think you're becoming an expert, so you can probably do it yourself, but I'll just do it anyways. This time, I'm gonna make this side 36. So if that side's 36, that means that's 18 and that's 18. So this point right here is 18 something. And similarly, this would be 18, 0. This point down here, this will be minus 18, 0, if I'm doing this correctly, which I believe I am. And this point would be minus 18 something. And we will figure that out. How you figure it out is, of course, with that. So y is equal to, when we have x equal to 18, and therefore 18 squared is 324 divided by 481. That's bigger than I thought. Okay, so obviously this is not drawn to scale, but that's okay. You guys understand. So we got 81. So area, the area from here to here is 81, correct? And then from there to there is 36. So 81 times 36, 2916. So that's the answer. And then finally part D. All right, so now we've got a little bit different. Let's draw this again. So we got this, and they want what? The length and width to be equal. Okay, so, well, let me see if I can do that. It's going to be a square then, right? The length and width are equal. It's a square. So, so that's, and the parabola is going to be something like this. Yeah, well, that doesn't look like a parabola. It looks more like a V, but you guys understand. Okay, well, let's go through this. So if the length and width are equal, let's say from here to here is A. So that means this coordinate would be something A, and this would be something 0. This coordinate would be something 0, and this coordinate would be something A. That's an A, by the way. Okay, so if this side is also A, then that means from here to here would be A over 2. Correct? Okay, so that's the coordinate of that point right here. Now the area, of course, would be A times A, right? So A squared. Yeah. Okay, now where do I go from here? Well, I guess we have to use that formula of the y is equal to x squared over 4. So that means y is A and x is A over 2. Okay, so that means 4a is equal to a squared over 4. And therefore a squared is equal to 16a. And therefore if we divide through by a, we get 16 equal to a. Oh, okay, that worked out. So that means a squared is 16 squared, and that would be 256. Oh, great. Okay, so 256 is the area of the parabolic rectangle whose length and width are equal. A triangulation of a regular polygon is a division of its interior into triangular regions. In such a division, each vertex of each triangle is either a vertex of the polygon or an interior point of the polygon. In a triangulation of a regular polygon with n greater than or equal to 3 vertices and k greater than or equal to 0 interior points, with no 3 of these n plus k points lying on the same line. No 2 line segments connecting pairs of these points cross anywhere except at their endpoints, and each interior point is a vertex of at least one of the triangular regions. Every regular polygon has at least one triangulation. The number of triangles formed by any triangulation of a regular polygon with n vertices and k interior points is a constant and is denoted by t and k. For example, in every possible triangulation of a regular hexagon and one interior point, there is exactly 6 triangles. That is, T61 is equal to 6. What is T32? All right, so I'm assuming you understood all that. And it's really not that difficult to explain. They take a polygon, like for example, that's a polygon, right, with 6 sides. And they put either 0 interior points or some interior points, because the number of interior points is greater than or equal to 0. So in this case here, there's 0 interior points. And then what they do is they divide it into triangles. And then they give it's denoted by this T something. So in this case, it's 6, 0. Why? Because there's 6 vertices and there's 0 interior points. And when they did that, they were able to create 4 triangles. And that's why it's equal to 4. Now, this guy over here, they still have 6 vertices, but then they put 1 interior point. So now it's become T61. And then when they cut those into triangles, they find that they're able to create 6 triangles, and that's why it's equal to 6. So that's all that is, really. So T32, I've got to, basically do that in my, like a diagram. So there's 3 vertices, so that's basically a triangle. And then I got to put 2 interior points. Okay, no problem. I'll put one there. one there, it doesn't really matter. And then now I've got to connect the dots and see how many triangles I can make. All right, let's connect the dots. Okay, I think that's pretty decent. So how many triangles did I make? 1, 2, 3, 4, 5, 6. Is that right? Or did I screw this up? 1, 2. Oh, no, sorry. This is, sorry, I think you gotta be careful, right? I extended this line a little too much. So that's actually just one triangle. There shouldn't be 2 dots there. All right, so okay, no problem. I'm new to this question too, so let me just get rid of that dot. Okay, no problem. So that basically means that T 32 is 5. And I've illustrated that as a diagram, so there you go. Now, T4 100. So obviously this one, I'm not going to draw 100 interior points and then connect all the lines. So we've got to most likely look for some pattern. Okay, no problem. Let's first draw a 4 vertices shape, which of course is either a rectangle or a square. And then let's find what is T40. Okay, T40 to me, it looks like that's all I can do there. So that looks like two triangles, one there, one there. Okay, let's keep going here. Let's try T41. So this time we have one interior point. So let's see when I have that one interior point, and I get 4 triangles. All right, let's keep going here. Let's do 2 more. I don't want to do too many. Hopefully I'll be able to get a pattern sooner rather than later. And then let's, I've got to put 2 points in, right? So let's put 1 point there and 1 point here. And now let's connect the dots. So 1, 2, 3, 4, 5. And then we're going to connect those. So that's 1, 2, 3, 4, 5, 6. Okay. So that means that T62 is equal to, oh, what am I doing? It's T42. T42 is equal to 6. Okay, so far so good. Now let's do one more. So this one is T43, right? T43, 3 interior points. So 1 here, 1 here, and 1 here. Now let's connect the dots. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay, so I have 1, 2, 3, 4, 5, 6, 7. Oh, I think I forgot this one. Yeah, I forgot that one. So that would be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that makes me think I have a pretty decent pattern here. I'm kind of comfortable with this. So that makes me think that T4n is always going to be 2 times n plus 1. And you can verify that works. So for example, when n was 3, it's going to be 3 plus 1, which is 4 times 2, which is 8. Okay, so that means that T4 100, this time my n is 100, it's going to be 2 times 100 plus 1, which is 101 times 2, which is 202. And that is the right answer. So as you can see, if you get the pattern, you can get a general formula and then plug in the number 100. Determine the value of n for which Tnn is 2020. All right, so Tn0, anytime that's 0, it's going to be n minus 2. And you can go back to part B to see that that is indeed true. If there's no internal points, then the number of triangles you create is going to be n minus 2. So for example, T40 was equal to 2. And you can see that earlier on. So that basically means that Tn0 is n minus 2. And then, if you noticed also from part B, when you add an interior point, what it does is it increases the number of interior triangles by 2. Right? You notice that. So this becomes n minus 2 plus 2. And that just becomes n. And then when you when you add another interior point, it adds another 2 interior triangles. So now this n, we have to add 2. And then when you go up to n3, it adds another 2, so it becomes n plus 2, which is n plus 4. And you guys get the point now. N4 would be n plus 6, and so on. So generally speaking, if we want to create a general formula, T of nk is going to be n plus 2k minus 1. All right, that's the general formula. So now we want this guy, TNN is 2020. So we want TNN to be 2020. Okay? So how do we do that? All right, well, this time it looks like T is equal to N, right? Sorry, what am I saying? N is equal to K. There's both N's there. So N is equal to K. So that means this TNN would be, if you use this formula, it would be N plus 2 times N minus 1, which is N plus 2N minus 2, which is 3N minus 2. Correct? And that's TNN. And then we're told that's 2020. Okay, so plug it in. 2020 is 3N minus 2. So this becomes 2022 is equal to 3N. And therefore N would be 674, I believe. Yeah. And that pretty much solves that question. Let xo be a non-negative integer. For each integer I greater than or equal to 0, define xi plus 1 to be xi squared plus 1. Show that x2 minus x0 is even for all possible values of xo. All right, so we got to put a few values here. So according to this definition right here, first we have xo, we're starting with that, and then x1 would be xo squared plus 1. x2 would be x1 squared plus 1, and so on. So this guy, x2 minus x0, by definition, would be x1 squared plus 1 minus x0. Okay, let's get everything in terms of one variable if possible. x1 is this right here, so I can put that in x0 squared plus 1 all squared plus 1 minus x0. Okay, so that's about as far as I can go. Now the only thing I can do is sort of simplify this, and I'll let you do that. I'll multiply it all out and collect like terms, and when you do, you get xo to the power 4, and I'm going to factor this 2xo squared plus 1 minus xo. So I didn't do anything fancy. I just expanded it and collect like terms. Now let's talk about this guy. This is an even number. It's 2 times something. So whatever this guy is, if you multiply it by 2, it will be even. So this is always even. Okay, great. But what about these two guys? So what about this xo to the power of 4 minus xo? We have to show that is even also. Okay, so let's see. If xo, just xo is even, then you'd have, like for example, the number 6, right? Or whatever, it doesn't really matter. Then this expression would be, right here, would be an even minus an even, which is an even. Got it? Now if xo is odd, let's say it's 5, you'd have an odd, that would become odd, and then this is odd. You have an odd minus an odd, and an odd minus an odd is an even. So what that means is that this will always be even regardless of whether xo is even or odd. So that means this entire expression therefore has all even components to it, and therefore it will always be even. That's pretty much the explanation. Show that x2026 minus x2020 is divisible by 10 for all possible values of xo. All right, so something is divisible by 10 if its units digit, the last digit of the number, is 0. right? So for example, 8760, that's divisible by 10 because its last digit, also known as units digit, is 10. Now, this is a subtraction of two things. Now, if two things subtract and have a result of 0 as the units digit, that means that their units digits were equal. So for example, if x 2026 minus x 2020, an example would be, let's say, I don't know, anything you want. If this was 4272 minus 3142, that gives like 1130. So that gives a units digit of 0, which makes this number divisible by 10. But that was only possible if they had the same units digit. So this had the same units digit as that one. So in this case, I have given them a units digit of 2. So that's just illustrating. So that means that you can write this out in words. X 2026 and X 2020 must have the same units digit. Whatever it is. It could be 3, it could be 5, whatever, but it has to be the same. In order for the subtraction, the difference should give a units digit of 0, which means that it's divisible by 10. Okay, so that's the approach. Okay, so then what do we do next here? Well, what we have to do is sort of assign, we're starting with x0, right? I mean, eventually you get up to x 2020 and x 2026, but you start at 0. So x0 has to be something. What is it? I don't know. So what we do is we kind of work with it. What's x0's units digit? So obviously it could be either 0, 1, 2, all the way up to 9, right? All right, so this is where we begin, and this is where we insert, we create a table. So let's put in that table. All right, so here's this really very nice table, and let me explain what's happening here. Okay, so we got XO right here. And XO, like I said, its units digit could be anywhere from 0 all the way to 9, right? Whatever it is. And then what we do is we calculate x1. And you guys remember the formula, right? It's up there. That guy. Let me just write it right here. So x1, I think I did this before, would be x0 squared plus 1, like that. Okay, that's fine. So if you take the units digit, whatever it is, and put it into this formula, then you try to figure out what is the units digit of x1. And this table shows that it's 1, 2, 5. Like for example, let's say x0 had a units digit of 4. Okay, well 4 squared plus 1 is 17. So x1 would have a units digit of 7, and that's why you have that 7 there. You got it? Then you do the same thing for x2. x2, according to my formula, or not my formula, the formula of the question is x1 squared plus 1. So same thing. Let's say we have a units digit for x1 is 5. So it'll be 5 squared plus 1, so that's 26. And that's why the units digit for x2 is 6. Got it? So then you just keep doing that for 3, 4, and so on. And one thing you should notice is that all the units digits for x1 are identical to all the units digits for which one? This one right here. Those two rows are identical. Hope you can see that. So that basically means that the units digits are the same. They repeat for every 6th row. So in this case it was x1 and x7. Example, x1 and x7. So if two terms are 6 apart, they will have the exact same units digits. Now, interestingly, our terms were x2026 and x2022, which are 6 apart. So they will also have the same units digit. Got it? And if they have the same units digit, regardless of whatever x0 is, when you subtract them, they will have a units digit of 0. And that means that it's divisible by 10. So You can explain all that in words, and that should be sufficient.